if I am equal to 0 to 1 integration x power n log x power m x dx, n is greater than or equal to 0 and m is a positive integer, then prove that I m equal to minus m upon n plus 1, I m minus 1, and hence find I3. So we write I m equal to 0 to 1 x power n log x whole power m dx. Now we integrate it by using integration by parts. So we take this integrable and this differentiable. So we can write it as x power n plus 1 upon n plus 1 times log x power m. Then we put the limits 0 to 1 minus integration x power n plus 1 upon n plus 1 times differentiation of this. So this will become m log x power m minus 1 upon x whole dx. If we put the limits log 1 is 0 and log 0 is also 0, so this term will become 0. So we will get Im equal to minus. Here, x power n plus 1 and this is x. So 1x will get cancelled. So we will get m upon this m and n plus 1 can be taken outside the integral symbol. So n plus 1 integration 0 to 1 x power n log x power m minus 1 dx. And this can be written as I m minus 1. So we can write it as I m equal to minus m upon n plus 1 I m minus 1. Now we have to evaluate I3. For this purpose, we will need I1, I2, and I3. So when we find I3, it will be minus here m equal to 3. So 3 upon n plus 1, and this will become I2. And when we put m equal to 2, we get I2 equals minus 2 upon n plus 1 I1. And when we put m equal to 1, we get I1 equal to minus 1 upon n plus 1 I0. Now, what is I0? We can get I0 from here. I0 will be equal to integration 0 to 1. This term will become 1. So, x power n dx will be there. We integrate it. So, we get x power n plus 1 upon n plus 1 limits 0 to 1. So, this will give 1 upon n plus 1. So, we have got the value of I1. But before that, this is I0, sorry, not I1. So from here we can get I1. So this will give I1 equal to minus 1 upon n plus 1 whole square. And we can put this value here to get I2. So we can write I2 equal to minus 2 upon n plus 1 times I1. I1 is minus 1 upon n plus 1 whole square. So this becomes 2 upon n plus 1 whole cube. So this is value of I2. Now we need I3 and I3 is this much. So we can say I3 will be equal to minus 3 upon n plus 1 times 2 upon n plus 1 whole cube. So this becomes minus 6 upon n plus 1 whole power 4. So that is our answer. Now let's take next question. Question 2 says, evaluate 0 to infinity integration x power n e power minus x dx, where n is a positive integer. So we can integrate it by part. So let's write it as I n. So I n will be equal to the use integration by part. So x power n and integration of this e power minus x upon minus 1 and limits 0 to infinity minus integration e power minus x upon minus 1 into differentiation of this will become nx n minus 1 dx, and the limits in both the cases 0 to infinity. If we put here infinity, then we will get 0. And if we put 0, so this term will get 0. So ultimately we will get 0 from here, then minus here. This is minus sign, this is minus 1, so this becomes plus. So we can say n times 0 to infinity x power n minus 1 into e power minus x dx. So we can write I n equal to n 0 to this thing, we can copy, or in place of this, we can write I n minus 1. So I n minus 1. Now we can generalize it. We find I n minus 1. This will become n minus 1 times I n minus 2. Similarly, so if we put this value here, what do we get? We get I n equal to n into n minus 1 I n minus 2. If we take I n minus 3, then 3 terms will be there. I n equal to n into n minus 1 into n minus 2. And this will become I n minus 3. So we can say if we reduce this value to till I0, so we will get factorial n here. So we can say I n equal to factorial n times I0. Now, so let's evaluate what is I0. I0 means here, when we put n equal to 0, this term will become 1. So we will be left with 0 to infinity e to the power minus x dx. We evaluate it. So this will become e to the power minus x divided by minus 1 times 0 to infinity. So we can write it as e to the power minus x 0 to infinity. So when we put x equal to infinity, we will get here, I think there is one mistake. So when we write its integration, it will become why this minus sign. There's only one minus sign here outside. Okay, sorry. So now if we put the limits, we will get I0 as 1. Now, if I0 is 1, so In will become factorial n. And that was our purpose. Let's go to next question. Next question says, if un equal to log x power n dx, then prove that un plus n times un minus 1 equal to x times log x power n. So let's write it. Un equal to integration log x power n dx. We can integrate it by parts. For that purpose, we have to multiply it by 1. So 1 dx, and assume this integrable term. So we integrate it, so we will get log x power n times x minus integration. Now we can differentiate it. So this will become n log x power n minus 1, and this will become x, and differentiation of log x will give 1 upon x dx. So x will cancel out. So log x power n times x minus n times log x power n minus 1 dx. Since un equal to log x power n dx, so this can be written as un minus 1. So un equal to log x power n times x minus n times un minus 1. We can shift this term to LHS. So un plus n times un minus 1 equal to log x power n times x. And that was to the proof. Thank you for watching.